Okay, so we're starting chapter 13. And chapter 13 is going to be area and volume that we're talking about. Today we're doing 13.1, areas of parallelograms. All right. Hold on. Oh. All right. Area is the number of unit squares needed to cover a region or surface. Okay. For example, this side would be 2 units, and this side is 2 units. So the area is 4 units squared. Little 2. The formula. Area equals base times height with this being base and that being height. And when the letters are next to each other, what do we assume is happening here? Multiplication. So it's base times height. Or area equals length times width. That's an L. Length, width. Length times width. So depending on the parallelogram, it's going to either be base times height or length times width.
So it's LW.
Length and width. When you're done, put your pencils down so I know that you're done. All right. Notice for area, the units are always squared. It's always squared. When you're dealing with area, your answer will always be squared. Volume is cubed, but today we're just talking about area. Okay, when we're talking about area, picture this classroom, okay? Picture this classroom. When people think area, especially when you're learning it for the first time, you think all of this area. And that's not true. That would be considered volume, okay? That would be everything in this room, the space, the air, everything. That's your volume. Area is just going to be like the floor, okay? Or the wall. Or just the ceiling. And like, for example, if I were to do, like, for example, what is the area of this board right here? Okay? They're not talking about perimeter where you just measure around the outside. They're not talking about the volume. You know, that means everything inside this board. They're talking about the area, which is what you see, the flat surface and everything in between. Okay? Do y'all understand that? A lot of times a good example would be if you're buying carpet. Let's say you're buying carpet for a house. Okay? Carpet would be done in area. What is the area of the living room where you're buying the carpet for? You measure it. Go and you buy the carpet and it fills the floor of the room. So that would be your length times width. Okay? You would measure one wall and then the other wall, multiply, and that gives you the area. So for example, let's pretend that I'm wanting to buy carpet for a room that's 13 by 15 inches. So, how much carpet do you buy? How much carpet do you buy? Whoops. That should be good. Okay, so if you're wanting carpet for a room that's 13 by 15 inches, how much carpet do you buy? That is basically, let's say this is your room. And this wall is 13 inches, and this wall is 15 inches. How do you go about doing it? Because you're wanting the carpet. This is the floor. You're looking at the floor, and you want the carpet to fill the whole room. So, Emily, how would I find that out? That's right. You're going to multiply. One wall is 13. One wall is 15. Up here, length times width. So you have your length times width. So you multiply. 5 times 3 is 15. 3 times 1 plus 1. Put my 0 there. 1 times 5, 5. And 1 times 1 is? And what do we get? 195 inches squared. Because it's area. So you would buy carpet that's 195 inches squared.
Wait, what is squared, or like, what does it mean? A square.
That when you're dealing with area, the units are always squared. And when we do volume, it's always going to be cubed.
Squares on the floor, or the square.
Okay, does everyone have this? Almost. You have it? Okay. Okay. Everyone got this? All right. So that is normal area, which y'all have all been taught before. Now we're going to be talking about parallelograms. Parallelograms also use the same formula as rectangles and squares. I put that in quotes because it's a little different. It's the same idea as what we just did. But instead of length and width, you're going to use the perpendicular height, not the diagonal. And I'm going to show you what that means. There's my parallelogram. Okay, so that looks quite different than the rectangle we just did for a typical square room, correct? Or squared up room, correct? Okay, so if this doesn't look anything like it, you may think, well, we'll just use this diagonal here. You know, length times width sort of thing. Absolutely not. You do not use the diagonal. You're going to use the height. Because watch this. If I cut this, down like that, that's supposed to be a straight line. If I were to cut that down, remove this piece and tack it over here, it becomes a rectangle. If I were to take that piece, cut it off, and stick it right there, it becomes a rectangle. Do y'all see that? Okay, so if you remember with the rectangle, it's length times width, right? So we wouldn't be multiplying this with the length or width or whatever, right? We'd be doing this, correct? It'd be this times this, yes? Y'all see that? Okay, well this is considered the height. That's your height. And of course, your base is either this right here or this right here. Either one. Any questions before I move on? I could just teach you everything and move on, but I want you to have a good understanding. Everyone have this? All right. Example. So let's do a parallelogram. There's my little indicator of a right angle. That means these two lines are what? Okay, but this line and this line are considered perpendicular. Here's the word perpendicular. So this line and this line are perpendicular because of the little square meaning right triangle. So let's say this line right here is 6.6 meters. Down here is 12 meters. The diagonal is 8 meters. Nope. But they're going to give it to you. So what Taylor's saying is, do we need to know this information? Don't need to know diagonal measurement. You don't need to know diagonal measurement. Okay, so what is the formula for parallelogram? It is area equals base times height. So then we just fill in what we know. What is the base, Cecilia? 12. What is the height, Michaela?
6.
That's right. And now you multiply it. 12 times 6.6. 6 times 2 is? Everyone? 6 times 1? plus 1. Write down my 0. 6 times 2 is? 6 times 1 plus 1. I get 7, 9, 2. Where do I put my decimal?
Right behind the 9 in front of the 2.
That's right. Because there's one place, one total place in the problem. So then there's one total place here. So then my answer is 79.2 meters squared. Don't forget that meter squared. Any question? All right, let's do another one. This time, you're given the area of a rectangle. Of 75 meters squared. And it says, and the base, they use that word base, is 6 meters. What is the height? So this time, up here, we were looking for area, correct? Both examples we've done, they were looking for area. Well, this time, they gave us the area and the base. This time, the question is, what is the height? And it doesn't matter if it's rectangle or parallelogram. It doesn't matter. Well, when do I use length times width, or when do I use base times height? Well, if they talk about base and height in your problem, then that kind of tells you right then and there which you're going to use. So which formula am I going to use? Area equals base times height. Now, all you do in this time is plug in the information. Do we know the height? We do not. Do we know the area this time, though?
We do.
And what is it?
75.
That's right. So we're going to put 75 in place of the area. Equals, do we know the base?
6.
It's 6 times height, just h. So, Cecilia, we've got to find h, correct? So how do I do that? That's right. We're going to divide both sides by 6 because we're isolating the variable. And I get, to save on time, 12.5 meters equals height. Why didn't I put square here?
Because it's not the answer.
Because it's not the area.
Bingo. It is not the area. Base and height is, look, here's base. It doesn't say squared right here. Height would not be squared because those are normal measurements. The only thing that you square is your area. So there you go. Any questions? All right, let's do some examples. Everyone have this down? Put your pencils down when you are done so I know. So you got it down? All right. So we're doing examples. Page 546 to 547. Let's start with number 2. Number 2 gives you a drawing, something similar to that. What is that, 5.2?
Yes, ma'am.
5.2 meters.
Yes, ma'am.
And then down here it's 4.3 meters. Okay, Izzy, how do I solve this? Sure. Area is base times height. So what it says, find the area. So we're looking for area, right, Izzy? What is the base? 4.3. And what's the height, Izzy? 5.2. Okay. Do the math, Izzy, and then tell me what you get. The rest of you are doing it as well. $22.36 meters squared. Good job. Any questions? All right. Let's move on to number 4. Number 4 this time, Number 4 is a parallelogram. And they have the diagonal as 7 centimeters. Then the base as 11 centimeters. And is that 6 centimeters?
Yeah.
6 centimeters. Emily, what's the formula for this? Area equals base times height. All right, Emily, what's my base? That's right. 11 is the base. What's the height, Emily? Huh? I don't know. You tell me. Look at the diagram.
Can't do that.
Okay, but you're right. You are absolutely right. We don't need this. But we're looking for, okay, that's right. Because this is the height. So you need to write that down. This is the diagonal. And I'm going to put an X by it. Because we do not need the diagonal. You do, however, need the height. Now, the example we did a while ago, they didn't give us the height. They gave us area, so we could plug it in and solve. This time they're asking us for area, and we have the base and we have the height. So, Emily, what's 11 times 6? So 66 centimeter squared, because we're looking for area. Do you understand? Again, we're looking for the entire area of this parallelogram. All right, look at number 6. Look at number 6. I'm not going to draw it. You look in your book. Michaela, again, we're still looking for area. So what is the formula? You need to be on the right page.
The area? What did you say?
Okay, Cecilia. We're looking, the directions say look for the area, so what's the formula? Very good. Okay, stay with us, please, Michaela. All right, so we're looking for area. Michaela, what would be the base? Very good. And Michaela, what would be the height? No. Which one? Why?
Because it's the dashed line.
Not necessarily. Okay, Cecilia, why is the height 4.5? You can't do diagonals. That's correct. And the 5 is your diagonal. Also, notice the height is going to be your perpendicular lines. Okay? All right, so Michaela, go ahead and solve. What is 7.8 times 4.5? $35 or 35.1 centimeters squared, because we're looking for area. Good job. So number 6 looked a little odd, but it's okay. You can still do it. All right. Now let's see. 7 through 10 and 11 through 13 are basically the same thing that we've been doing. Okay? It's the same thing. You just got to be able to know which is the base and which is the height. Okay? Because these are going to be turned in weird directions. You just got to know which is which. Now, let's see. Let's look at 14. Down in B exercises. This says, find the base or height of the following rectangles. In this case, they give you the area, which is 56 inches squared, and they gave you the base, which is 8 inches, and they expect us to find the answer. So, Joanne, given this information, what is it that we're looking for? That's right. So what is my formula, Joanne?
H equals
H?
A equals B times H.
Very good. Now, this time we have area, so what do I put here?
56 inches.
Or you can just put 56 right now. And then, what do I put in place of B? And then what about h?
Just H.
Oh, very good. All right, so Joanne, how do I solve for height?
You divide 56 by 8.
That's right. We're going to isolate the variable by doing the opposite. And Joanne, 56 divided by 8 is? So it's going to be 7 inches equals height. We don't square it because it's not area. Any questions? I'm going to be setting y'all free pretty soon, so if you don't understand, you better ask questions now. All right, everyone has this? When you're done, put your pencil down so I know. All right. Moving on to the last example, 24. All right, look at this.
Like this.
Okay. Now, in this case, we have to find the area of this whole thing. We have the measurement for this side right here, which is 2. Y'all better pay attention. We have the measurement for this right here, which is 4. This right here, that's 3. This is 3. And this is 6. So we've got to figure out how we can do the area of that whole thing. All right. First of all, based on the picture itself, we don't have the measurement for this line, or this line. What you would do in a case like this, and their drawing, of course, in their book is much better, but you could break this off into individual rectangles. You could cut it there, and we could cut it right here. So now do you see that I have 3 different rectangles here? Y'all see that? Okay, so question. Let's start filling in the missing places. Can we easily figure out the area for this rectangle right here? How would I do that?
6 times 3.
All right, so this right here, this piece would be 6 times 3. That whole length times width or base times height. What do you get?
18.
All right, so that's 18. So let's try to figure out this one now. Is it going to be 4 times 2?
Because
The 4 only goes to here, right? So 4 is not the whole side. It's just partial side. So we can't use 4. But what about this? Look in your book. What would this be?
6.
That's right. It's going to be 6. Because if this is 6, and in your book it's a better drawing, then this one is going to be 6. So then this would be
12.
6 times 2 equals 12. Now the only thing left is this one right here. This middle one right here. We have 3, but we don't know what measurement this is. Or do we? We have 4.
And we also have 6.
And we have the 6. So what would this line or this line be?
2.
That's right. This little line is going to be 2 because this is 4 right here. This is 4. Y'all better have your eyes on the board. If this is 4 and this whole thing is 6, then you subtract and you get that this is 2. Y'all see that? Okay. So then we have 2 times 3, which is?
6.
So now we add all 3 up.
Oh,
Yeah, because we're going to add this area, and this area. 18, 12, and 6. We're going to add them all up, and we get 36 centimeters squared. That's the area for the entire figure. Any questions? It's kind of like a mystery. All right. I'm going to set y'all free since no one has a question.
How do you tell whether to use base times height or?
I've already explained that. When do you know when to use it?
If it has base times height.
Yeah, exactly. And both of them are the same, so it really doesn't matter.
Oh, that's.
You're doing page 546 to 547, numbers 1 through 25 odd. 27 is bonus. Ooh.
I remember bonus at the beginning of the year. That's so easy.
This is due Tuesday. We'll probably have a quiz Friday. Probably. I gotta check and see.